Good morning, everybody, and welcome to another Prokon Know-How episode where we'll be covering part two of modeling stairs in SUMO. So part one just covered the basics of modeling a staircase and its landing, sort of what you'd be looking at within SUMO. And part two will cover modeling circular stairs. Now, to be honest with you, I really have no idea why you would want to do this analytically, but I will show you how to do it nonetheless. All right, so jumping straight into SUMO, what we'll do is we'll need to load our materials. So I've already loaded some metal and concrete, so 30 MPa, and then I loaded a circular section to serve as the central column for my circular staircase, and I might just adjust its size a bit later on. All right, the first thing I want to do is I want to create my step. So I'm going to go into my top view, put my grid snapping on, and go to plane shells. In the properties panel, the thickness is 10 mil, mesh size is 0.1. We might even change that. And then I made sure that the steel material is selected. So I'm going to snap to that. Well, I should be snapping to that 0 point there. Let me just try that again. There we go. So there's 0, 0, that's the origin. And I'm going to make the step length 0.75 meters. Going to turn grid snapping off, and the step size or width is going to be 300 millimeters, so 0.3 meters. You can check there, I use tab to switch to the polar distance. Press tab again to switch to the polar angle, and I make that 0 degrees. And there you have a nice 90-degree line. And then I'm going to snap back to the start point and press accent. All right, there's my step. Now I'm going to place my column. So I am in the analytical model view. That's why you're just seeing this analytical line. I'm going to snap to the origin there. There we go. If I go to volumetric, there you can see the column and the plane shell's thickness. All right. So now what we need to do is we need to create our circular pattern basically. So I'm going to select the step, press copy. My step height is going to be 150. Snap to that point, turn grid snapping off, otherwise it's going to be terrible. But make sure that in the nearest snapping is on. See, I step to the column, tab, and change that to 0.15. Press enter and press enter again. And there's my first step. Okay, so now I need to rotate the step around this axis. So go to insert, add a line from there to there. I'm going to select that plane shell, click rotate, snap to that point, and then I'm going to change to my top view to make sure I'm rotating in the correct plane, and I'm going to snap to that point over there. Right, now I'm going to modify this plane shell a bit. Click modify. I'm going to change this line to there and change this line to there and hit accept. Right, now I'm going to repeat that process. I'm going to select the plane shell, copy it up, 0.15, insert that line, select the plane shell, rotate, snap to the rotation center, then to that point, top view, and rotate. And there we go. So I'm going to do a few more of these just quickly, just so that we can see just a nice pattern forming there. I'm going to do one more. Now it's starting to take shape, so you can see what this is now. But this workflow can be used in other circumstances, so it's nice to know that you can do this. All right. And then I want to close off these gaps. So I'm going to add another plane shell. There we go. So let me close off those as well. All right. All right, you could choose what to do with the side as well. You can actually put in plain shells over here. So if I do this, I can just keep on doing this. Of course, this is a bit time consuming. There's really not a considerably faster way of doing this specific thing, just because it falls more into the advanced category, I would imagine. Right, but that looks quite nice actually. So what I want to do then, so I'm just going to add a support here quickly. So fully fixed support, just so we don't have any stability issues. And I'm going to create, it's a load case, it will be self-weight. Check it, my analysis type is set to linear for now. And let's see if we can actually run an analysis. I think the meshing might give us some problems, but there we go. All right, so just going to get this grid view out of the way quickly. And this is what we've got actually, which is really cool. So there's not a lot going on here. So let me actually go back. We put on some area loads there. So a slab load won't work here because it won't snap. So I'm just going to put on some area loads, 1 kilonewton. I guess we can even make that 0.5. I'm going to snap to each one of these steps. It might actually have quite a nice effect for us. Okay, I'm going to leave that bottom one for now. Let's just run our analysis again. And there's actually not a lot of deflection. I think because it's quite stiff, especially with these sides. So I'm going to delete these sides quickly. Now they should be quite, I think the effect will be quite significant now. Not even really. Hey, look at that. There's not a lot going on there. All right, but you can imagine if this is all welded plate, especially if it's 10 mil welded plate, that it actually would be very stiff. So now what you can do, we can go to our shells, and here we can look at our membrane stresses, our plate stresses. Okay, membrane should have membrane shear stress. There's our von Mises stresses. So actually here the stress would dictate the design then. And that's about it. To be honest with you, I wouldn't know why you'd exactly want to model it this accurately, but just so that you know that it is possible, that it's something you can do. And maybe these techniques could even be used to model other things within SUMO. So I really hope that you enjoyed that. Thank you so much for tuning in, and check out for some of our other upcoming videos. Please remember to leave a like and subscribe. And if there's anything specifically you want to see me demonstrate in YouTube, please do put it in the comment section below, and I'll make sure that I make some time to get to it. So thank you again, and hope that you have an epic day.